Well, good morning and a very warm welcome to this awards ceremony. I think it's probably fine to say that this is one of the highlights of. Am I audible? Yeah? Yeah. Okay, so welcome to this awards ceremony, which is certainly one of the highlights of SAT. We will present several awards in this session, starting with the Best Papers, Best Student Papers Award, progressing to the Test of Time Award, and then finally to the Fahim Bacchus Award. I mentioned a bit about these prizes yesterday already in the business meeting, but today is the real time to see what these prizes are about, and of course, more importantly, who will get them. Can I pass to Jakob for the Best Paper Awards?
Sure. I mean, we're going to start by describing the process briefly before, just to maximize the suspense. So what we had, it's going to be riveting. In any case, that I can tell you. I mean, so what we did during the reviewing phase, we of course reviewed all papers, and then towards the end, the chairs put together a prize award committee consisting of 4 persons, and I'm the one here, so I got to present our work. And once all the papers were in, and I think once we also had access to all camera-ready versions, we could then go over the papers and nominate papers to be considered for award. So this was like the first round, looking at the papers and submitting votes, collecting them from the whole committee. Okay, this was the first round. And then in the second round, this committee got to work and should select, and we were tasked with selecting the best paper, best student paper, and also some quote unquote runner-up papers that could also be invited to a journal. So that was the process, and I would like to say it's worth describing this process in some detail, maybe because this is being done, I think, differently in different years, and there's a large sort of amount of variation in how different SAT committees have been doing this. I would say my experience from different committees I've been serving on, I kind of like this approach. I like that you have several rounds where like you get feedback from the whole committee, and then also having a smaller award committee that could then discuss and hash out the details. I think it worked well. I think we were happy with this. Well, I hope the chairs were also happy with this. In the end, this was a very light task because we basically, I don't remember it, this was Nikolai Björner who said that we sort of got all the votes and then we said, okay, do we see any reason to sharply disagree with what clearly the whole conference committee already thinks, or should we just certify sort of the clear conclusions of the whole committee? And so both the best paper and the best student paper that you are seeing now were more or less, I mean, this was a strong consensus within the committee. So without further, oh, okay, thank you. So without further, which order are we doing this? So I'm doing this? I'm not doing it. Okay. So the best student paper award then. One of these, did I want to say something more about the, okay, so let me maybe spend the suspense didn't quite turn out the way I planned it, but maybe 60 seconds more about the award deliberation process, because Olaf tells me we have time. Yeah, so the best student paper and the best paper that you've maybe already seen, both of them, these were easy decisions. I mean, there was a clear consensus within the whole committee, and we basically just signed off on this. For the runners-up, there were a bit more discussion. Still, there were there was a fairly clear committee consensus, but then the problem is I think our initial count was to somehow nominate 2 runners-up, and then we discussed, and we have had real problems because there were like 3 papers, and we felt like in the end we said, like, do we really have to throw one of these out, or could we go with 3? Because there were sort of 3, and then there were other good papers that were discussed, but somehow these 3 we felt like they were. Yeah, that is also one thing to discuss for maybe in Glasgow we'll do that, but somehow in the end we were told we could give 3 runner-up awards, and then it was sort of all clear. So in the end, light work, at least, you know, these are apples and oranges decisions, right? There's no clear right or wrong, but I think it's fair to say that we feel quite happy with our decisions, and I think they reflect the consensus within the whole SAT committee, more or less 2024. So if we erred, you know, we're all erring together, pretty much. Okay, so without further ado, the best student paper is Speeding Up Pseudo-Boolean Propagation by Robert Neuenhaus, Alberto Oliveras, Enrique Rodriguez Carbonell, and Rui Zhao. And as the citation says, for the principled approach used for measuring the impact of implementation choices for pseudo-Boolean propagation. And here I should point out that what several people who nominated these papers pointed out, and like what we really liked is what also was, for those of you who were here at the paper presentation, if you want to measure these kind of things, like how do you isolate a specific aspect of the solver and measure it, when we all know that changing just this aspect ever so slightly will change the whole solving process. And now you're measuring this aspect of a completely different solving process. And so we like the sort of scientific way of saying that we want to measure only this, and then making sure that the solver in all other respects behaved more or less the same. So I think this is, and then also the very systematic way of performing the investigation. So yeah, how do we do this? Will the SAT chairs maybe come up and give the award, I think? Or I do this? So do we have any of the authors here? They could please come up. Please. So, and the best paper award is not there. It's here. It is awarded to the paper The Strength of the Dominance Rule by Leszek Kolodziejczyk and Neil Thuppen, for the use of theoretical tools from mathematical logic to answer a question of considerable applied interest regarding the strength of different methods for proof logging. And I should want to say here, to elaborate briefly on this citation, that what we particularly liked is maybe what also I personally believe is the strength of this conference, that we gather researchers from very, very applied areas using SAT to solve industrial problems, as we just heard, for instance, in the previous sessions, all the way to these people doing things in mathematical logic that even I, as a theoretician, have no clue what they're doing, and you know, I cannot even understand it almost. And we're spanning this whole range of different research directions somehow connected to SAT. And what you see in this paper is when they somehow come together. So when these very applied questions about proof logging and certifying results from applied SAT solvers and the strength of these methods can be analyzed by tools that were designed for completely other questions, I think it's fair to say, in mathematical logic. So, and I think this is sort of, again, very nice illustration of the SAT conferences at its best. So Neil Thuppen, I guess, is here. So please come to receive the award. Please. And now I don't know if I will get the, now I just keep paging. Forward. Okay, let's see if we can do this together. Right. So now we have 3 runners up, and I'm not presenting them in any particular order. So the first runner-up paper that I want to present, which is the runner-up for the Best Student Paper Award, by Irfan Shaikh and Jaco van der Pol, for the paper Optimal Layout Synthesis for Deep Quantum Circuits on NISC Processors with 100+ qubits. So please. Yeah. And second, the SAT 2024 Best Student Paper Runner-Up Award, the paper Quantum Circuit Mapping Based on Incremental and Parallel SAT Solving by Yang, Yaroslav Kharkov, Yunong Shi, Marijn Hoyle, and Bruno Duterte. And wait for it. Right. And then I think we, by simple counting, but we know this is hard. Counting is a challenging problem, but I think we have one more paper by Franz Xavier Reichel, Friedrich Slivovsky, and Stefan Zeider for the paper eSlim Circuit Minimization with SAT-based Local Improvement. And with that, I think I leave the word to Olaf again.
Yeah, thank you very much, Jakob, for presenting this, and congratulations again to all the winners. I can maybe add that there is some prize money for the best paper and the best student paper award, which comes from the association. You will have seen that also in our accounts yesterday. So our treasurer, I mean, we don't have bags of money to distribute here, but our treasurer will be in touch with the winners and arrange for the transfer. So you don't need to worry about it. It will arrive. Yes. Well, we do pay in euro. Okay. So next prize that we have is the Test of Time Award. And again, as with the previous prize, before we come to the actual award, let me say a few words on this prize. It's a relatively recent prize that we established by the SAT Association. We had it for 2 years now. The first one was in Haifa, second one was last year in Alghero, and this is now the third one. So the idea is to honor one paper which appeared at the SAT conference and which has significant long-term impact. And we look at the SAT proceedings at the SAT conference 20 years back. We don't want to make it too pedantic, so we are looking back 21, 20, 19 years. This is exactly these 3 years that we've been considering, and we are moving forward within time and see which of the papers from that period had long-term impact. It's an award given on behalf of the SAT Association, and we are planning to do this annually at the SAT conference. As I mentioned, first award was given in 22. Many of you will remember that this first award went to the mini-SAT paper, which certainly was a very good candidate for such a first award. And the purpose, I mean, I state it again perhaps, is to honor and celebrate important contributions, but also increase visibility of SAT to a wider community. And I think such an endeavor is really important on behalf of SAT, that we showcase a bit more what we are doing and the impact our research has. So how do we select the award? As with the previous prize, we establish a committee, which is Matti, Martina, and myself. And as I mentioned, we look back 20 years plus minus one. So we looked at the sixth SAT conference, which was taking place in Santa Margherita in Italy in 2003. We looked exactly 20 years back, where we were in Canada, in Vancouver, and 19 years back, where we were as next year in Scotland, St. Andrews. Well, I mean, there are lots of papers which appeared in these three conferences. So how do we actually proceed in looking at which paper has the best test of time impact? Well, I mean, Jakob mentioned already, counting is one approach that we can do. So we initially looked at citations. Although I have to say I'm not a great fan of that metric. It gave us a first impression on what papers maybe to zoom into. So we didn't look only at citations, but we also considered wider impact and further points. But as a starting point, we did look at citations. And of course, now the big question is, who is the winner for this year's Test of Time Award? And I'm pleased to give my many congratulations to Tiang Sang, Fahim Bacchus, Paul Beam, Henry Kautz, and Tony Pitassi for their paper Combining Component Caching and Clause Learning for Effective Model Counting. So you see this. So you see this is a paper which appeared exactly 20 years back, and you see it's a paper in model counting. So if we look back at the prizes that we gave for the Test of Time for the last two editions, you see actually that SAT has quite some depth and breadth. So I was saying that 2 years back, the first prize went to the mini SAT paper, so a core contribution in SAT solving. Last year, Armin received the prize for fundamental work in QBF, in fact. And this year, we are giving it to model counting paper, so which also exemplifies that over the years, these topics really had a dominant place in SAT. And I mean, we didn't really have to push for this selection. It came out naturally in the papers that we looked at. I wrote to all of these people well in advance, but unfortunately it turned out that neither of them could make it to the conference. But all of them responded, except Fahim, of course, because unfortunately he's no longer with us. But I must add that we were also very pleased that for all the achievements that Fahim has had and for all the contributions he made to this community, we could even honor him post-mortem with this award and show that his work really has impact. So I wrote to all of the other authors, and all of them came back to me and were really excited to get this award. And on their behalf, I pass my thanks and my best wishes, their best wishes to the congregation here. But yeah, none of them could come. Here you see the award, which again states that this is the test of time going to these 5 people. And I'm now very pleased that Moshe has agreed to give a laudatio on this paper and explain to us a bit more in detail why this was a worthy recipient for the test of time. Thank you, Moshe, for agreeing to do this. I mean, Moshe has worked on many things, but we know he is in particular also an expert on model counting. And
so I'll try to explain I'm not privy to the reasoning by the award committee, but I think they made a fantastic choice, and I'll explain why I fully agree with the award committee. So counting started by a paper in 1979 by Les Valiant on the complexity of enumeration and reliability problems. When you read the paper, it's a pure theory paper. And in fact, the main point of the paper, it defined the notion of sharp P, which is just you have an NP, you have a Turing machine, not a missing Turing machine, running polynomial time, and you want to know sharp P is counting how many accepting computation it has. And then it is actually trivial to see that sharp SAT is sharp P complete because we have the Cook-Levin encoding of Turing machines run by SAT formulas, so that's obvious. And actually, this was not the interest of Valiant in that paper. The main point that Valiant was trying to make in the paper, you could have a problem where the decision problem is easy, but the counting problem is still hard. That is really the main point of the paper. In fact, he had another paper looking at computing the permanent, also proving the permanent is sharply complete. And computing the permanent is like counting how many perfect matches you have, which is, again, easy, but for bipartite graph, it's an easy problem. So in that paper, sharp SAT kind of is a marginal thing. That's not the main point of the paper. When does sharp up become a little more significant? That was actually quite a few years later by a paper by Dan Roth from 1996 on the hardness of approximate reasoning. And Roth relates model counting, weighted model counting, with probabilistic reasoning, where you're given a graphical model and you're trying to compute probabilities of some events. But if you look at what the paper is trying to do, it actually says, look, these problems are reducible. So we know that weighted model counting is sharply hard, therefore probabilistic inference is hard. So the main point of the paper here there was to use probabilistic inference to show the probabilistic inference is hard using sharp SAT. So sharp SAT here is a source of complexity. This paper kind of turned it around in some sense. It says, wait a minute, we think we can actually solve sharp SAT in practice. Therefore, we will be able to do probabilistic inference in practice. So they said, look, there have been major progress in SAT solving. Let's figure out if we can take the progress in SAT solving and translate it into progress in sharp SAT solving. And if we can do that, then we can also attack probabilistic inference. So they kind of, one of the things they have, in fact, they had a follow-up paper a year later performing Bayesian inference by weighted model counting. So they have taken, they went back and looked at the equivalent shown by Dan Roth, but instead of looking at it to say, oh, probabilistic inference is hard, it's like what we now say about some problem, oh, they're NP easy. So, you know, this is kind of, so this is basically, they've shown that probabilistic inference is sharp SAT easy. And therefore, let's do sharp SAT and let's leverage the progress we've made in SAT solving. And of course, they wanted to use the most recent progress in SAT solving. So first, they had a paper already in 2003, actually interestingly in Fox, about the idea of component caching, which is to look at these joint components of the formula and being able to count for component and cache the result and then combine them later so you don't have to repeat the counting. And that's not too difficult to do for DPLL. I have to go and look back at the Fox paper. I'm curious how it was accepted to Fox, okay? This is, I mean, we have had later my students, Kuldeep Mill, try to submit papers on counting to Stock. And he had nice theory and experiments that showed that the theory worked. And the program committee says, experiments, not here. And they rejected the paper. They didn't say the theory is no good. You've done experiment, not in our school. But the observation of this paper, the award-winning paper, was that DPLL is pure search. So it's very kind of relatively straightforward how to do component caching. But by now we have the new class of algorithms, CDCL, and we have closed learning. So they say closed learning is a form of information recording and caching components. Component caching is another form of recording information, but there are two very different types of information. So how can we combine both? It's really not straightforward at all. So, and the kind of the challenge is that learning clauses don't change the satisfying assignment space. So they don't affect the counting. But they change the search tree. Once you add a learn clause, the search will be different. And so this is the challenge, and the details are quite non-trivial, and I thought of trying to explain them here, and I realized that's not will be a good use of our time right here. But here is just a quote. Our algorithm put these ideas together. It performed component analysis along with closed learning, exploring the subtree below a component in order to compute its value. The learn clauses serve to prune the subtree and thus making exploring it more efficient. The computed values are cached and used again to avoid recomputing already known values. So it's if you try to think quietly for yourself, can I figure it out in 5 minutes how to do it? The answer is no. It is quite a sophisticated way of combining closed learning and component caching. So why this paper? Why do I agree with the award committee? This paper stood the test of time. First of all, they built the tool. It was significantly performed earlier tool because it was based on CDCL. And it actually kind of demonstrated that CDCL is not only for such solving, but CDCL is a fundamental approach. And now we're using it everywhere. You know, we're using CDCL for model counting, we're using CDCL for QBF. We figure out how to take this idea and use it everywhere. And this paper definitely shows how you can use it for model counting. And it shows that the same way that we have come to the conclusion, oh yes, SAT is NP complete, but we can solve it in practice. Now we think, well, sharp SAT is sharp P complete, but we can solve it for non-trivial problem in practice. And so that kind of suddenly put sharp SAT to say, well, let's work on it. Let's develop better and better solvers. So there is much follow-up research about this because suddenly sharp SAT has come down from the peak of complexity theory to, oh, well, we can do this in practice. And in fact, some of their ideas, other sharp SAT solvers have built on their ideas. And the tool, the tool has been still maintained, and we're still running experiment today on sharp SAT solver. We're still comparing to Cache to see how we perform. So in that sense, this paper clearly stood the test of time and is highly deserving of this recognition. Good choice.
Thank you very much, Moshe. So this brings us to our next award, which is the Fahim Bacchus Award. This is a brand new award, which we are awarding this year for the very first time. So I would like to use a few minutes to say something on this award, because from the title you can't even guess what kind of award it might be. Yes, well, that is quite clear, and that's my very first point. It is an award in honor of Fahim Bacchus. I mean, many of you will remember Fahim. Fahim made really significant contributions to SAT, to many areas, practical and theoretical. He was also the chair of the SAT Association for a number of years. In fact, he was my immediate predecessor, and he almost died in office. I mean, we know that he tragically passed away 2 years ago. We had also a memorial ceremony at SAT last year for Fahim. And yeah, we really thought that this would be a good way to honor his life, his achievements, to establish an award in his name. And all the people we asked and contacted about it, Jessica Davis, for instance, they were very grateful that we could do this, and we're very pleased that Fahim would be honored in this way. So this is the new Fahim Bacchus Award. As Moshe is saying, it's an award in honor of Fahim Bacchus, but what else do we want to do with the award? Well, it's an award for one outstanding PhD thesis, which has been recently defended. So you see, if we compare the Test of Time Award and this Fahim Bacchus Award, it's really different ends of the spectrum at research for SAT that we see. One is for a paper 20 years ago with long-term impact, One is for a PhD student to a young researcher, which just appeared just now. So recently defended is maybe something that we can interpret a bit flexibly. I'll say in a moment how we did that for this time. Purpose of the award is quite clear: to honor and celebrate important contributions. Again, is I think an award that increases visibility of what we do in SAT, and is a particularly good thing to promote the work of young researchers and help in their career in SAT. How did we go about it? I mean, again, and in England, there's a saying: whenever you have a problem, you form a committee. So that's what we did here as well. It's mainly the board of the association. So it's Armin, Stefan, Martina, and myself. We issued a call for nominations. You probably have all received that because it went around in the mailing list, for instance. The idea is that we want to honor one outstanding PhD thesis in the field of satisfiability, but very broadly interpreted. So all the aspects that you see here represented at SAT are eligible. It doesn't have to be on SAT solving. It can be on QBF, model counting, any of these areas. Theory, practice, could be a thesis in proof complexity. All of these would be eligible. And since this was the first prize, we thought we would look at a 2-year window. I mean, we might re-examine this and have a prize now for 1-year windows and for future editions. It's again a prize that we plan to award annually. So you will have a next prize at the next SAT edition. But for this first one, we looked at 2 years, and the rule was that the thesis should have been defended between 1st January 22 and December 23. As I mentioned, we had a call for nominations. Deadline was in May this year, and we asked for quite an extensive package to evaluate the things. So we received letters from supervisors, the reviewer reports for the thesis, of course, the thesis itself. We looked at the PhD certificate, last not least, and we also looked at copies of relevant papers by the nominee. And we received a number of nominations, and it really surpassed our expectations, I have to say. I mean, both the number of the sheer number that we got, but more than that, the high quality of the submissions that we got. I mean, I know from other awards committees that they get maybe two nominations and then, well, spend lots of time on discussing who should get the award. We actually got 5 nominations. Maybe I can tell this much. And I think each of the nominations was of such quality that we wouldn't have been ashamed at all to give the prize to the candidates. So it took us quite some time to actually make a decision. We looked at several aspects. In the end, we thought 3 of them really stood out. So again, we wanted to have this idea of runners-up and give the award to one thesis in the end, but also mention and acknowledge the achievements of the runner-ups. So I'll start with these. And the 2 runners-up are Stefan Gocht from Lund University for his thesis on certifying correctness for combinatorial algorithms by using pseudo-Boolean reasoning, and André Schiedler from TU Vienna for his thesis on scalability for SAT-based combinatorial problem solving. I don't have certificates for them now. Unfortunately, neither of them is at the conference here. But as I said, both of them were really of outstanding quality, accompanied by numerous strong publications. I mean, the publication record that we looked at for PhD thesis in this committee was really astounding. And yeah. Of course, now the real question is who is the winner? I should say that the runners-up are also acknowledged in the proceedings. So I didn't want. I mean, if you could have looked it up before. We wanted to really increase visibility. So we made a conscious effort to have all the prizes that we award today for future reference in the proceedings, in the front matter of the SAT proceedings, which is also something that increases the visibility of the prizes that we give. So I don't want to build suspense any longer. So who is the winner? The prize goes to Dominik Schreiber for his PhD thesis. Scalable SAT solving and its applications, which he defended at the Karlsruhe Institute of Technology in 2003. Can I ask you to come forward, Dominik, please? Congratulations, Dominik. It's really a great achievement. I've got some certificate for you here. Yeah, in fact, we have heard about Dominik's thesis already here at this conference. I mean, he gave a very nice talk at the POS workshop in advance, which I think contains major part of his thesis, and also he presented here at the SAT conference. So you should be familiar with what he's been doing, and I'm sure you agree that he's really very worthy of getting this award. Dominik, do you want to say a few words?
Yeah, so thank you very much for the kind words, and of course for this award, which is in honor of Fahim Bakus. Unfortunately, I never had the opportunity of meeting him in person, but everything that I know about him makes me even happier to receive this award. As somebody who's also has ties in the automated planning community and in the SAT community, and who surely also likes to participate in the respective competitions. So this is really great. I want to thank the committee for making this choice for this great recognition. Yes, and I also need to acknowledge that, of course, I didn't do all of the work in the thesis all by myself. There have been great people along the way. I've been very fortunate to work with Peter Sanders, who was a really great supervisor to me. My co-authors, Marijn, Mike, Don, and Benjamin. We had a cooperation of for one of the chapters in my thesis, and everybody else whose works I build upon. Like, of course, the absolutely impressive sequential solvers of Armin, Tomáš Balio, who authored Horsesat earlier, which provided like a foundation, and who also supported me along the way and was actually the reason why I got motivated to pursue the topic of SAT solving. So his course was why I began specializing in that. And to everybody else who I worked with and who joined me along the way. Yes, so going forward, I'm going to be doing pretty much more of the same. So as a young investigator group leader at Karlsruhe, and I'm still trying to push the scalability of automated reasoning in parallel and in distributed systems. And this week I've really heard really many nice use cases and applications of SAT and related tools. So if you have the feeling that your use case might benefit from parallelism, just as we saw earlier today with the quantum integration, then I invite you to maybe take a look at my work, or perhaps even reach out for some kind of cooperation. I would really love to continue working with the people in this great community here. Yeah, so this has been a really nice conference, really great and inspiring so far. Like, we will see what the competitions bring in the afternoon. Yeah, so thank you, Olaf, and the entire committee, and everybody for organizing this. Thank you.
Thank you very much. And I should say that there's also prize money from the association for this award. So again, I don't have the money with me, but our treasurer Stefan will be in touch. Maybe I can say that this is 1,500 euros that we give for the best thesis award, for the Fine Bacchus Award. Many congratulations. Now, can I ask Armin to say a few words why we made this choice and why this is a good thesis that is definitely worthy to receive this first award?
Yeah, so I should say Olaf just asked me in the last break, you have enough time. Okay, so I planned for doing it for 2 minutes. Now I had to come up with a story which lasts a bit longer. Okay, so let me start with this one. First of all, regarding the selection of this was highly, so I've been in these committees before for a long time, like in Austria, for instance, in this selection of best. And there's always the problem that you have all this conflict of interest. So, and in this particular case, it was really bad because I had actually close connections to all the three top, actually was reviewing his thesis, and I was co-supervisor of one of the other guys. And of course, I also think that Stefan Gocht had some lasting impact. So actually, it was very difficult for me to be in this committee. But this was kind of expected, right? That if you're in such committees, actually nobody wanted to do this when we formed the committee last time. So this is exactly why, right? Because you have all these conflicts of interests. So I was on his committee, and I wrote actually a 4-page review, a very long one. And maybe I should start with this before I dive a bit more into what he actually did. So I have plenty to say, of course, because I wrote 4 pages. This was really useful because maybe I can leak this now, like the chairs leaked it in the proceedings. He not only now got this prize, he will get next week, it's official, so please don't tell anybody. The best PhD thesis in German-speaking countries, actually. So maybe we can already congratulate him for this one. And in addition, maybe I should not say this, I tried to hire him because I knew. And now I'm actually even more happy that he got this nice position. So this comes as a kind of a junior professorship. And of course, I welcome that he stays in the academic system and got this nice opportunity to continue with these prizes. But now maybe I should tell a little bit about his thesis work. Actually, so I should start with the coffee this morning. So I think somebody asked me about, so Dominic was also there. I don't know who asked me about sort of this parallel solving. And then I had to say, okay, so the first paper where people really do CDCL parallel solver, this was actually by Dershowitz and Siad Hanna, so the CTO of Cadence. We heard about this already before. And then Alex came into the room. There's Alex, because Alex was of course he did his PhD with Dershowitz, and this is a very highlight, this paper, in my also parallel computing course. Why? Because I pick up the paper, and there's a table with like a 2-core Intel machine and a 4-core Intel machine. It has numbers 2.3, and for 4 cores, it had 6.8. And then you read the paper closely and see, oh, these are not speed ups, these are slowdowns, okay? So it was a negative result, that paper. So this was kind of the first time somebody did sort of CDCL. I think it was around 2004. Do you remember, Alex? Yeah, 2004 or something. So it was completely clear. Parallel SAT solving CDCL doesn't work, right? So this was that paper. I don't know where they published it. I forgot. Does anybody remember? So Dominic also told me that he remembers citing this paper, but I forgot now where it was. It's interesting. It's a real milestone. So I use this in the parallel computing course. Yes, putting synchronization in code makes your program first slower. Anyhow, then as many of you know, then the history went on with this ManySat paper, right, where they actually this was called then portfolio, which is actually a misnomer, and because actually what this makes these parallel solvers work is that they share clauses. And this is this highlighted ManySat paper, and Dominic's approach falls into the same category. But even there, so we had a BANF SAT meeting. This was a very nice one. When was this? 2013. And there was a presentation by Ashish Saprahal from IBM. So he did the kind of largest sort of survey on how parallel computing, parallel CDCL works. And he got scalability until 16, and then you saw the same thing as with the Dershowitz paper, right? So the running time actually went down, okay? And now to make maybe the story short, Dominic's approach is really the first one where you see increase of scalability until I think the latest experiment is with 3,000 cores. So you see an increase of scalability if you throw more cores in it. The efficiency is still not really sort of like in his thesis increases efficiency from 6% to 14%. This is how many of these cores you're actually using. And of course, companies like Amazon are really happy about this because they tell you you can pay for 3,000 times more cores, right? And then you get like 14% out of it, right? So this is also one of the points I have in my report, and I'm going to cite it actually in a minute, is that this work had a really large impact. So Amazon goes around with his figures and shows this is why we have this automated reasoning, the progress and everything. So this has huge impact for the whole community. One also has to say, so this is an immense engineering effort he did. I mean, this is sometimes overlooked in dissertation work, and I think, like, it's fair to say, I think he had two years of his thesis are just about programming, not about like writing papers. 3 years, he says, okay. And so this is maybe also one is of course close to me because I also like this implementation aspects, but also this huge impact in the practical side is for me really a reason that he deserves it. Maybe I finish with quotes from my report. Okay, so the thesis has 9 chapters, and 3 of them are really the core. So one is this, which we completely didn't talk about yet, is this malleable thing. So the idea is there that you sort of, you have, let's say, your Amazon, you have a big cloud, and you want to run, of 500 people, you want to run parallel servers, right? And then sort of the number of cores each user would get might change because now it becomes suddenly cheap or whatever. And he has a framework where this is made possible. So the kind of dynamically increasing or decreasing the size of the number of cores you're using. This is also the reason for the name, like malloc means malleable. And then of course the next chapter is about applying this to SAT. Okay, and this is kind of the real impact because he came up with this malloc solver. And the the next chapter is then putting even proofs into this in a parallel way. So he did this together with people from Amazon. And well, it has 9 chapters. So this, as he already said, he has also applied it to planning as a second application, and also there it was possible. So anyhow, so let me finish by citing myself. To summarize, this outstanding thesis presents the state-of-the-art parallelizing the most important NP hard problem, in particular propositional SAT solving. It is very detailed and very well presented. 2, this thesis work already produced exceptional impact in a highly visible field, both on the academic as well as the industrial side. Yes, and with this, let's congratulate him again.
Much, Armin. Well, this actually brings us to the end of this award session, so I hope you don't mind if we finish a bit early. Many congratulations to all the winners again, and I guess we will have lunch in a while. And any further announcements to make? No. Ah.